All right, so most of us are pretty familiar with 3D printing by now, right? The idea that we can create basically any object we want, layer by layer. But what happens when we take that idea and push it a little further? Today, we're going to talk about the next giant leap, 4D printing. So, if 3D printing is all about height, width, and depth, what in the world is this mysterious fourth dimension? Is this some kind of sci-fi concept we're talking about? Well, not exactly, but it's every bit as revolutionary. The fourth dimension is time. Yeah, that's the secret sauce. See, 4D printing creates objects that don't just, sit there after they're made. They're actually programmed to change, to transform themselves over time, all based on the world around them. So here's our game plan. First, we're going to unpack this whole new time dimension. Then we'll get into the cool science that makes it all possible. After that, we'll look at some mind-blowing applications, weigh the hype against the reality, and finally, take a peek at what this transforming future could really look like. This really is a fundamental shift in how we think about making things. We're moving from printing static, kind of lifeless objects to creating things that are dynamic, responsive, and honestly, almost seem alive. Let's break it down real simple. With 3D printing, what you see is what you get. The final product is, well, final. But with 4D printing, the object that comes off the printer is really just the beginning. The real magic happens later, when it starts to transform and assemble itself. But how does it know when to change? It's not random. These transformations are actually triggered by specific things in the environment. Think of it like a set of instructions just waiting for the right command. And that command could be something as simple as a change in temperature, a little bit of sunlight, contact with water, or even a specific chemical. And that brings us to the science at the heart of it all, these incredible smart materials that make self-assembly possible. This is where the engineering gets really, really clever. So this whole technology depends on a few key types of programmable materials. You've got things like hydrogels. They're kind of like super sponges that just swell up when they hit water. Then you have shape memory polymers, which are plastics that can literally be programmed to remember a different shape and snap back to it when you say heat them up. And liquid crystal elastomers, which allow for these really controlled reversible movements. These are the building blocks of transformation. So how does it all come together? Well, first, engineers actually embed the design, the instructions for how to change right into the material itself. Step 2, they print the object, layer by layer, just like normal 3D printing. Third, you introduce that trigger. You add water or you apply heat. And finally, step 4, you just watch as the object follows its programming and transforms. All on its own. And what's so wild is that the huge fold or expansion that we see with our eyes, it's all happening because of millions of tiny, microscopic polymer chains rearranging themselves. These little tiny molecular shifts all add up to create that massive visible change. It's really bottom-up engineering at its absolute finest. Okay, so the theory is fascinating, but what can we actually do with this stuff? Let's check out some of the incredible applications that are already starting to move from the lab and out into the real world. In medicine, the potential is it's staggering. Imagine a medical stent that can be printed flat, making it super easy to insert into a tiny blood vessel. And then, once it's inside your body, it just self-expands into the perfect shape. Or think about a drug capsule that's designed to release its medicine only when it reaches a specific part of the body that has a certain temperature. We're talking about truly personalized healthcare. And the scale gets even bigger when you look at aerospace. Launching things into space is incredibly expensive, and a big part of that is size and weight. Well, 4D printing would let us print huge structures in a really compact form and then have them unfold themselves once they're in orbit. And back here on Earth, you could have airplane wings that literally morph their shape during a flight to be more aerodynamic, saving enormous amounts of fuel. And this technology could end up right in our hands too. Picture a phone case that can heal its own scratches when you apply just a little bit of heat. Or what about shoes that don't just fit you when you buy them, but that actively adapt to the shape of your foot as you're walking around all day? This isn't just a gimmick, it's about creating smarter products that actually last longer. Now, as exciting as all of this is, it's really important we ground ourselves in reality here for a second. Because like any brand new technology, 4D printing is facing some pretty significant hurdles that we need to think about. So let's take a balanced look. On one hand, the promise is these amazingly adaptable, smart materials. But the current reality is that they often don't have the strength or durability we need for big jobs. We want perfect, precise control over these transformations. But even a tiny error in the design can cause the whole thing to fail spectacularly. And yeah, personalized products are awesome, but the automation of self-assembling things could have a huge impact on manufacturing jobs. So, keeping those challenges in mind, where's all this heading? Let's zoom out a bit and look at the truly profound long-term possibilities this technology is opening up. Researchers aren't just thinking about a box that folds itself. They're imagining a future with self-repairing infrastructure, like buildings or bridges that can heal their own cracks. They're even exploring the wild, maybe a little scary idea of self-replicating materials that are inspired by biology. And it all leads to this world of truly personalized manufacturing, where objects adapt not just to their environment, but to us, using our own data. And that really brings us to this powerful core idea. 4D printing isn't just a new way to make stuff, it represents a real philosophical shift, a move toward a world where the materials all around us are no longer passive things. They're active, they're intelligent, and they are just alive with possibility. So, I'll leave you with this final thought to chew on. We are right on the edge of a world where our objects aren't just static tools anymore, but they're dynamic partners that adapt and evolve with us. So if our physical world is no longer passive, what does that mean for our relationship with it? And more importantly, what does that mean for us?